Hey everyone, and welcome back to The Explainer. Today, we're tackling a fundamental yet incredibly powerful skill in mathematics, Algebra 1, Unit 1, Lesson 6, Combining Like Terms. If you've ever stared at a sprawling, messy algebra equation and felt a sudden wave of panic, hey, don't worry. You are in exactly the right place. We're going to learn how to clean up that mathematical mess step by step. Okay, let's dive right in. So, picture this algebraic expression, 3x plus 5 plus 2x minus 1 plus 4y. Honestly, at first glance, a long string of numbers and letters like that looks completely terrifying. It looks chaotic, right? Kind of feels like a random jumble of math soup. But in the world of algebra, we have actually a highly logical system to simplify these expressions so we can see the big picture perfectly clearly. To make sense of all this chaos, we use a really simple concept. Think of a fruit basket. You intuitively know that conceptually you keep the apples on one side and the oranges on the other. You wouldn't just mash them together and call the resultant app orange, right? That's ridiculous. You just can't combine completely different items into a single new category. And while in algebra, it's the exact same sorting metaphor. We literally cannot combine completely different algebraic terms. We have to group the matching items together. So here is our roadmap for today. We'll start with basic algebra vocabulary, move to the steps to combine like terms, put it all into practice with some curriculum examples, and finally, look at some common test traps you'll want to avoid. All right, Section 1, Basic Algebra Vocabulary. Let's build that toolkit. Let's break down our first critical definition. What exactly is a term? Well, a term is either a constant, a variable, or a product of both. If we think back to the expression 3x plus 5 minus 2x, we actually have three distinct terms there. They are 3x, positive 5, and negative 2x. Think of terms as the individual separate Lego bricks of your entire math problem. Next up is the coefficient. Fancy word, but a super simple concept. A coefficient is just the number that is multiplied by a variable. It's essentially telling you the quantity of a specific item you have. So in the term 3x, the coefficient is 3. It tells us we have 3 of those x items. In the term negative 2x, the coefficient is negative 2. It's always the number sitting right in front of the letter. Then we've got the constant. A constant is a reliable number standing all by itself whose value never ever changes. It doesn't have a variable attached to it. Great examples would be the numbers 5 or negative 7. They are exactly what they sound like. They are constantly just that number, no matter what happens to the variables around them. And now we reach the star of the show. Like terms. The absolute crucial point here is that like terms are terms with the exact same variables raised to the exact same exponents. For example, 4x, negative 7x, and plain old x, those are all like terms because they all share that identical x variable. However, 3x and 3x squared, no way. Those do not match because the exponents are different. Same thing for 5x and 5y. They don't match because the letters themselves are different. They are the algebraic apples and oranges. Moving right along to Section 2, Steps to Combine Like Terms. This is the action phase. Okay, here's your clear, 3-step blueprint for simplifying absolutely any expression. Step 1, identify and separate your terms. And listen, you must mind the sign to the left of the term. That sign is superglued to that specific term. Step 2, rearrange similar terms together. Group your apples with your apples and your constants with your constants. And finally, Step 3, add or subtract the coefficients. This is incredibly important. When you add or subtract those numbers in front, the variable part stays exactly the same. You don't change the letters and you never change the exponents during this step. All right, Section 3, Practical Curriculum Examples. Let's actually put this into practice. So let's look at a single variable example to see how easy this can be. We have the expression 5x plus 3 plus 2x minus 1 plus 4x. We're going to conceptually divide this into two families. First, the x family. We grab our 5x, our positive 2x, and our positive 4x. Adding those coefficients, 5 plus 2 plus 4 gives us 11x. Next, we group the constant family, positive 3 and negative 1. 3 minus 1 equals positive 2. Put the whole shebang together, and our final perfectly sorted result is 11x plus 2. See how much cleaner that is? The chaos is totally gone. Now let's tackle a slightly harder multivariable example. We've got 3a plus 2b plus 5 minus a minus 4b plus 7. Take a look at the a family here. We have 3a and a minus a. Remember that negative a has a hidden, invisible coefficient of -1. So 3a minus 1a leaves us with 2a. Next, the b family. Positive 2b and negative 4b gives us negative 2b. Finally, our reliable constants. Positive 5 and positive 7 equals positive 12. Bring the families together, and our final result is 2a minus 2b plus 12. Everything is beautifully sorted. Finally, Section 4, Common Test Traps. Let's make sure you avoid these mistakes. Here is the number one trap I see, ignoring the sign to the left of the term. Think about the expression 7 minus 3x plus 2. The right way to handle this is to take the negative sign with the term. That isn't just a 3x being subtracted from a 7, that term on its own is actually negative 3x. The wrong way, and a really common mistake, is ignoring that sign and treating 3x as a positive term, leaving the subtraction sign just floating out in the void. Always, always remember, the sign to the left is absolutely glued to the term on its right. The second trap is mixing up exponents. Let's compare 4x squared and 3x. The right way to handle these is leaving them completely separated because their exponents differ. One is squared, one has a hidden exponent of 1. The wrong way is catastrophically smashing them together into 7x cubed or 7x squared. Please don't do that. Remember our core definition of like terms. The letters and the powers must perfectly match to be combined. If they don't match exactly, just leave them alone. So, let's recap our journey today. We've defined our basic terms, we've mapped out our 3 core action steps, we've practiced grouping our different mathematical families, and we've learned how to dodge the biggest traps on the exam. You literally have all the tools you need now. The next time you see a terrifying, chaotic equation, just remember, it's really just an unsorted fruit basket. So now that you know how to organize it, what complex equation are you ready to simplify next? Keep practicing, and I'll catch you on the next explainer.